Okay, lecture 14. So we're talking about exponents. So let's review the properties of exponents. Radicals. And we're going to do rational exponents later. So let's see this sign, square root sign. So in general, we have this. We have m's root. Let's see, use the variable x raised by n's power. And what does this mean? This means inside, so let's say this equals y. And this means y, some y raised by m's power equals to x raised by n. Let's see this one. In this case, we have 36 raised by 1. If we want, we can write 36 into 6 squared. 6 raised by 2, 6 squared, which is 36. And the outside by this sign also carries a number. So little 2 here. And we have a name for them. So this 2 is called the power or exponent. And this 2 is called the index. Index. So sometimes it's a little bit difficult to grasp the idea of index. You see the index m is here. Right? So let's say the equals to some y. So basically this equivalent expression is in some y raised by m's power equals to x raised by n. Okay. So in this case, if we want to write in that case, we can write as, let's say we don't know. But we don't know what the number is. Let's call it x, or let's call it y. And we can write as y squared equals to 6 squared. Just by coincidence, here we have m and n are the same. Well, y squared equals to 6 squared. Now this power are the same. So the forces, the base have to be the same. So y equals to 6. But normally we don't do this. So this is just helping us to understand the idea or the concept of index and the power. And later on, we're going to write as a rational exponent. So x raised by a fraction. The numerator in the fraction is the power, and the denominator in the fraction is the index. Right? So later on, we're going to talk about this. And this will help us to calculate. Okay, now let's go back to the first one. All of this just to help us to understand the concept. Usually we know square root of 36 is 6. Why? Because 36 is 6 squared. And the index and the power are the same. If we want to write it in this case, rational exponent. So we would get a 6 raised by 2 over 2. Well, what's 2 over 2? 1. That's a 6 raised by 1. Well, usually when something raised by 1, we don't bother to write the 1. We just write as 6. So that's A. Now let's see B. B, inside we call radicand. So X in here, so everyone has a name. This is called a radicand. Right, N is the power, M is the index, X raised by N is called radicand. So inside the radicand is a fraction, a square root of a fraction. So we can do this. We can square root the numerator. We can square root the denominator. Now we know square root 4 is 2. Why? Because 4 can be written as 2 squared. The square root of 49 is 7. Why? Because 49 is 7 squared. The index is 2. The index is 2 by default. So whenever m equals to 2, we just don't bother to write 2 over there. So when you do not see a number with this radical sign, That's by default is 2. Now we have 2 raised by 2 over 2, which is 1, plus 7 raised by 2 over 2, which is get 2 raised by 1 divided by 7 raised by 1, which is 2 over 7. Let's see 2. 2, the radical here is negative 5 squared. Let's think about negative 5 squared. Because if we write as negative 5, that's wrong. That's wrong. Because so far we're talking about real numbers. Real numbers. We cannot have square root of negative number, square root to be a negative number. Why? Because if we have a square root of x equals to y, this is the square root. That means y squared equals to x. So in real number systems, so y, no, x, when you square that, when you square anything, it has to be non-negative. But later on, we're going to talk about imaginary numbers. And we do define something as I squared equals to -1 to deal with square root of negative numbers. But for now, we're still in real number world. So if we square anything, that has to be non-negative. So how do we reason this one? So -5 squared, we know that's same as 5 squared. Because -5 times -5 is positive 25, right? -5 times -5, that's positive 25. And 5 squared is 25. So this basically we read as the same as positive 5 squared. So it equals to 5, not -5. Now let's see B, because this index is 2. Now the index is 3. Let's see if this one equals to y. So we can write as y cubed equals to -x cubed. This is the odd number. And then the -x cubed can be written as -x raised by 3. Because -1 raised by 3 is still -1. Right? We can think this as -1 multiplied by x raised by 3. And -1 is the same as -1 raised by 3. And then we put them together, that's -1 times x, which is -x raised by 3. So in this case, it equals to -x. Right? You don't really need to write this, but this just helps us to understand what is going on. Or you can think this way. You have, because this is odd, whenever the index is odd, we just carry on the sign. It's different from here. If this is 2 or any even index, right, we cannot have negative inside the radical signs for real numbers. Right? We can think of this as -x 3 over 3, right? Because the power is 3, the index is 3. And that is a negative x raised by 1, which is just -x. You can think that way too. Now B is hard to see, so I'll do D, B, C later when I move up the slide. Now let's see this one. This negative sign is outside the fourth root, because the index is 4, the fourth root of 81. So what do? When we simplify this, we just carry on the negative sign. We carry on the negative sign. Then we think about the fourth root of 81. When the index is 4, we can read as fourth root. Fourth root. 81 is 3 raised by 4. Multiply 3 with 3, that's 9. 9 multiplied by 9, that's 81. So 3 raised by 4 is 81. Now we can think rational exponents. Right, the index and the power are the same. The 4 divided by 4, that's just 1. So equals 3. So this equals to 3. But we have to carry the negative sign with us. So the answer for this is -3. Let's see E. E, we cannot do anything because this is a negative number inside the radical sum. And it's not in real number system. So we just say does not exist in real numbers. But so far, we haven't learned imaginary numbers yet. So for now, for this one, this cannot be simplified, does not exist. Does not exist in real number system. But it does exist in imaginary number. So when we will learn this later. Let me move up the slides. Let's see C. C, we have 8, we have B raised by 3. So we can split them as cubic root of A, the index is 3, because this is A multiplied by B raised by 3, right? Then multiply by cubic root of B raised by 3. 8 can be written as 2 raised by 3. So then we see we have a 2 raised by 3 over 3 times B raised by 3 over 3. Right? We just got a 2B. Now let's see F. F, we have x squared plus 4x plus 4. If we remember the formula, and this equals to x plus 2, parentheses squared. Right? X plus 2, x, the first one square, x squared is this one. The second one squared, 2 squared is 4 is this one. The middle term is 2 times x times 2. 2 times x, 2x times 2, 4x. So square root, then this is square root. So we have x plus 2 raised by 2 over 2. Well, this is x plus 2 raised by 1. But because we're in real number system, we want to force this to be non-negative. So we need to put an absolute value around it to make sure this is not a negative number. Because this is a perfect square, right? If x plus 2 itself is negative, the square will change the negative to be positive. So we need to put an absolute value around this, x plus 2. Let's see 3. So we want to rewrite in radical notation and simplify as possible. We have this rational notation. So basically we have x raised by n divided by n. So the exponent is a fraction. And in the radical form, that means, oh, let me change this. Let me keep my, let's change the numerator to be n, the denominator to be n. So this means the index is n, and the power is n. We can always switch those two notations. This is the radical form. This is a rational exponent form. So in this case, 25 raised by half, or 1 is the power of 25. And this 2 in the denominator is the index of 25. So which just means a square root. We don't really need to write down the 2. Square root of 25, which we know that's 25 is 5 squared. Right? Just equals 5. Square root of 25 is 5. Let's see B. So I have 16, power is 3, the index is 4. And 16 itself can be written if we want to simplify, but that's the meaning, because we don't really want to go through this route to simplify. When we try to simplify or multiply in the future, performing any operations, we prefer rational exponents. Because in this case, you can simplify, because 16 is 4 squared. So just write 16 to be 4 squared, then raised by 4/3. Now we have 2 layers of exponents. When we have 2 layers of exponents, 4 raised by 2, then raised by 3/4 again, we just multiply those 2 exponents. Then 2 is 2/1. Right? 2 simplified with 4. That's 3. 4 raised by 3/2. Right? But the 4 is 2 squared. 3/2. Then we have 2 times 2 raised by 3/2. Which is just 2 raised by 3, which is just 8. Actually, from here, let me change my color. This 4, we can change to be 2 raised by 4, because 16 is 2 raised by 4, right? Then go from there, 2 raised by 4 times 3/4. 4 times 3/4, 4 multiplied by 3/4. Remember, this 4 is numerator, and this 4 is in the denominator, so we can switch to be 4 divided by 4 multiplied by 3. 4 divided by 4 is 1. Okay. So usually we don't need to write down this step. We just see, okay, this is in the numerator, this is in the denominator, they cancel out to be 1. Then 2 raised by 3 is 8. Now I need to erase. Let's see. C have 5xy squared as radicand, and their power is just 1. So 5xy squared. And the denominator of the exponent is 4. So this 4, the index is 4. And then this cannot be simplified. Right? So this means something, let's say t. Equivalent means t raised by 4 equals to 5xy squared. Now this cannot be simplified, we just leave as it is. Now let's see d. D, we see the exponent is 2/3. And we want to write 27 to be negative 27 to be negative 3 raised by 3, 2/3. Because 3 times 2/3 is just 2. Right? Because this 3 cancel with this 3. That's a negative 3 squared, which is just positive 9. How do we write this in radical form? We write it so the index is 3. The index is the denominator in the exponent, right? Denominator 3. So it's the index. And negative 27 raised by squared. Because you see negative 27 raised by 2/3. So I need to keep the parentheses with me. But after simplifying, that's just 9. Let's see 4. So rational exponent. So here we can think 30x as one thing that's raised by 1. So we can write as 30x parentheses 1/3. Let's see b. B we can write as 3x squared y to the 5th power divided by 1/6. And if we want to keep going, we can write as 3 raised by 1/6 x, because this 3 is raised by 1, right? 1 times 1/6 is 1/6. X raised by 2/6, and the y raised by 5/6. And 2/6, of course, can be simplified to be 1/3. Very tricky to move the slides. Okay, let's see this 5. So we want to rewrite each one with a positive exponent. So we need to know one thing. If we have 1 over 2, we can write it as 2 raised by -1. Just notation, okay, negative exponent. Just a notation. -1 just means this, just means 1/2. So what happened here? The exponent is -1. It's 1 over 2 raised by +1. So this is the definition. So if we have x raised by -1, the definition means this is 1 over x. But if we have 1 over x raised by -1, that becomes 1 over 1 over x, which is just x. So if we have x raised by -1, y raised by -1, x raised by -1 becomes 1 over x. And this y raised by -1 in the denominator becomes 1 over 1 over y. So that becomes 1 over x times y becomes y over x. So what happened? What happened here? You see, when x has a negative exponent, it goes to denominator to have a positive exponent. When the denominator has negative exponent, it goes to the numerator to have a positive exponent. So more example. If I have x raised by -3 divided by y raised by -4, and this becomes y to the 4th power, x to the 3rd power. So we just switch. Whenever we see the negative exponent, if it's in the numerator, we change to denominator to have positive exponent. If it's in the denominator, have negative exponent, we switch to the numerator to have a positive exponent because of this definition. Okay. But this is the rule of thumb. So let's see this one. So we have a raised by -1/3. So that means we can split it as a raised by -1, then raised by 1/3. Well, a raised by -1 is 1 over 8. Then raised by 1/3. That's one way to think about it. Right? Then of course we can rewrite this as half raised by 3, then raised by 1/3. Because 1 over 8 is half times half is a quarter, quarter times half is 1 over 8. And then this just becomes 2. Because 3 times 1/3 is just 1. So 2 raised by 1, not 2, half. We have 1/2. Or we can do this way. So 8 is 2 raised by 3. Then we have this -1/3. We multiply 3 with the -1/3, we have 2 raised by -1. Well, what is the 2 raised by -1? That's half. Okay, either way. Let's say B. 27 is 3 raised by 3. We can write as 3 raised by 3 times -2 over 3. Well, that's 3 raised by -2. Because this 3 cancels with this 1/3. And 3 raised by -2 is 1 over 3 squared, which is 1 over 9. It's 6. 6, we have this radicand. So let's write down the radicand first. So we have 27 m raised by -6 n raised by 3. Then each one's exponent multiplied raised by this exponent. So 27, actually I want to rewrite 27. 27 is 3 raised by 3, right? So then everyone raised by 2/3. So I need to multiply the exponent. I need to distribute this exponent to 3. Distribute means multiply. Multiply by this, then multiply by this. So because 2 layers of exponents, we multiply them. So I have a 3 raised by 3 times 2/3. I have m raised by -6 multiplied by 2/3. I have n raised by 3 now times 2/3. So you see 2/3 is being distributed to everyone. Now I just simplify the exponents. So I have 3 raised by, well, this 3 cancels 1/3. So I have 3 squared. And this -6 divided by 3, that's -2. So m raised by -2 times 2, -4. And n raised by this 3 cancels 1/3. So n squared. 3 squared is 9. N squared positive. But this m raised by -4 goes to the denominator with a positive exponent. So in the end, we have 9n squared divided by m raised by 4. Now let's see B. B, I have same base. So I'm going to move the same base together. So x raised by 4 times x raised by 5/4 times y raised by 3 times y raised by 2/3. Same base, we add the exponent. So 4 plus 5/4 times y raised by 3 plus 2/3. So notice the difference from here. So this, we have 2 layers of, you see, we have 3 raised by 3, 3 raised by 3, then again raised by 2/3. So we have one base, we have 2 layers of exponents. So we multiply the 2 layers of exponents. But here we have same base, so we add the exponents. What's the principle behind it? Let's give an example. Let's see if I have 2 raised by 2, then raised by 3. So I claim that's 2 raised by 2 times 3, 2 raised by 6. Why is that? So 2 raised by 2 raised by 3, that means I have 2 raised by 2 times 2 raised by 2 times 2 raised by 2, 3 times, right? That's where this 3 comes from. So this 3 means I have 3 2 raised by 2 multiplying each other. Now each 2 square is 2 times 2. 2 times 2 for this one, 2 times 2 for this one, 2 times 2 for this one. So how many 2's multiplying each other? 6 of them. So that's why we multiply. We have 2 layers, we multiply. But now if I have 2 raised by 2 times 2 raised by 3, now you see I have same base. I have 2 raised by 2, 2 raised by 3. 2 raised by 2 means 2 times 2. 2 raised by 3 means 2 times 2 times 2, 3 times. So how many 2's multiplying each other? 5. So that's why this equals to 2 raised by 2 plus 3, which is 2 raised by 5. Okay, so be very careful with the difference up here. So that's why here we're adding the exponents. So when we add, we get x raised by, well, let's write this one. So usually only when we, during the calculation, we want to write as rational exponents. And normally we like to write as n's power m's root with the power and index. So for this one, we see we want to do 4 plus 1 plus 1/4, right? Because 5 divided by 4, that's a 1 plus quarter. The same thing for y. Y 2/3 is smaller. So it's okay. We can keep 3 plus 2/3. Now this 4 plus 1, that's 5. So we have x raised by 5 times, we want to split them. We have x raised by 5 and x raised by 1/4. Then times y raised by 3 times y raised by 2/3. Actually, in the beginning, we don't really have to combine those two exponents because this exponent is less than 1. But these two, we want to combine them because 5/4 is bigger. Okay, so now we can write as this. We can write as x raised by 5, y raised by 3, and this one is the 4th root of x. And this one is y squared cubic root. Okay, so in the end, we want to write in radical forms. And we consider this as a simplified version. Okay, let's do this. Okay, now let's do B here. So B, we can write the numerator as y raised by 2/5. Denominator y raised by 3/10. Same base division is subtract exponents. Minus 3/10. So now we need to calculate 2/5 minus 3/10. So we multiply 2/2 for the first one. That becomes y raised by 4/10 minus 3/10. Right, that becomes y raised by 1/10, which is y raised by 1 with 10th root. So the index is 10. Oh, I did B first. Actually, I still have A here. That's 7. So this index is 2. Index 2. So when we have layers of index, we also multiply them. 2 times 3 is 6. So that becomes 6 root of x. Let's see, 8. 8, we want to evaluate this radical function. So x equals to f of 6, negative 6. So we just write out f of negative 6 equals to square root of 4 minus 2 times negative 6. You see, we just substitute the x with negative 6. So read this as input. So what does the function do with input? The function does 4 minus 2 times the input and square root. Now the input is negative 6. So 4 minus negative 2 times negative 6 square root. Then negative 2 times negative 6 is positive 12. 4 plus 12, 16. Square root of 16 is 4. So f of negative 6 is 4. So that means evaluate. Evaluate at this x value means find f of negative 6. Let's see 9. So similarly, we just substitute x into 17 minus 9. Well, 17 minus 9 is 8. So cubic root of 8. Remember, 8 is 2 cube. Then we have 2 raised by 3/3. This is 2 raised by 1 equals 2. So this is f of 17. F of 17 equals 2. I think that's all for today. Let me check. Oh, we still have 10. 10 is talking about the domain of the rational, the domain of the radical function. So remember, what does this mean? If I have 4x minus 20 equals to y, and this means y squared equals to 4x minus 20. And in real number world, remember y squared has to be non-negative. So that means 4x minus 20 has to be non-negative. So I just solve for x. I move negative 20 to the other side to become plus 20. I divide by 4 on both sides. So x has to be greater than or equal to 5. If I don't want to use interval notation, let's see, the domain of the function is this. Any number greater than or equal to 5. Okay, that's it. I'll see you later in class.